Hi, my name is Arush and I'm going to be talking about electrofuels. And we are going to be looking at how they're synthesized, their advantages, disadvantages, and their future prospects. So firstly, what are electrofuels? Electrofuels are basically synthetic versions of our like already existing fuels such as diesel, kerosene, etc. And they have mainly two components which are hydrogen and carbon, like any other fuel. So here the hydrogen is captured using the electricity derived from a renewable source such as solar or wind, and carbon is captured using various techniques, and this hydrogen and carbon are used together to synthesize this e-fuel. One key advantage of using this e-fuel is that it has significantly lower emissions, and the infrastructure or design that is needed for these fuels is already present because it has similar combustible properties as the already existing fuels. So let's see how electrofuels are made. There's a small video about it.
Global challenges often require complex solutions. The sustainable design of our energy supply and mobility can be seen as one of the major challenges for society. Experts agree only the combination of different technologies will result in a climate-friendly solution. Most importantly, the existing fleet of cars, trucks, airplanes, and ships have to make their contribution to protect the climate as well. E-fuels have the potential to become a substantial part of the future's clean energy supply. In some areas, for example, the aviation or shipping industry, there is no other alternative. But what exactly are e-fuels and how are they produced? The basic building block of any fuel is hydrocarbon, which is a compound of carbon and hydrogen. To produce an e-fuel, this chemical compound is simply reproduced synthetically. The required carbon is either captured directly from the air or taken from industrial plants. Green hydrogen is produced, breaking down water chemically into hydrogen and oxygen using renewable energy. The required green energy comes from renewable sources such as solar, hydropower, or wind energy. In a synthesis process, a crude oil substitute is produced as a first step. Afterwards, this can be refined into petrol, diesel, jet fuel, lubricants, or even wax. The main advantages of e-fuels include the ease of storage capacity and transportability, even over long distances, and the possibility to proceed using the existing infrastructure of cars, trucks, airplanes, and ships in a climate-friendly manner. For more facts and news around the topic of e-fuels, visit efuel-today.com.
So as seen in the video, first water is taken and split into hydrogen and oxygen. This splitting is done using electrolysis, and the electricity source is taken from any renewable energy source such as solar, wind, or hydro. The second step is the carbon capture. So carbon dioxide can be captured from various sources such as industrial emissions and effluents, biomass processing effluents, or it can just be directly captured from the air. So this hydrogen and carbon is used for the synthesis of this fuel using various methods such as Fischer's-Tropsch method. So next, this is as we can see that this isn't just a theoretical concept that can be applied in the future. It is actually taking place, and like it's happening right now, and it's done by various countries such as Norway, US, Sweden, and Japan. In Norway, there's a company called Norsk E-Fuel, which is setting up the first commercial plant for aviation fuel. In Sweden, airlines and energy companies are teaming up to produce big volumes. And in the US, a company called Infinium uh, is already making e-fuels for Amazon's trucking fleet. And in Japan, Mitsubishi is investing heavily in this CO2 capture. So it's not just a theoretical concept that can be used in the future. It is happening like right now in the present. So next is the carbon neutrality potential. So here, if the whole system is powered by renewables, then electrofuels can be almost carbon neutral. So you're basically recycling carbon instead of like digging up new sources or pulling out carbon from the ground. You're just recycling it and using it again. So like there's no like carbon emission or like excess emissions. So next is the applications part. So where these fuels are mainly used is where batteries can't be used, because batteries in the current scenario they haven't been designed to like uh, they haven't been designed to like get as much as power as compared to like normal fuels. So here the various places they used are aviation and shipping and heavy transport. And here also there's an advantage that we already have the infrastructure that's needed to run these e-fuels. So there's no additional cost of redesigning or anything like that. So next are the disadvantages. So firstly, cost is obviously a factor that we have to account for, because the first step, which is the splitting of water into hydrogen and oxygen, is taking place using a renewable electricity source. So that's obviously costly. Like the high initial cost of capital is very high. And second one, the carbon capturing part is also quite costly. And thirdly, policies of industries encourage them to just capture the carbon and store it. And they don't encourage them to convert them into fuels and use them, like recycle them and use them again. And one more thing is that technology hasn't matured enough. So it's not like a common sight to be seeing e-fuels used everywhere. So this is the life cycle of an e-fuel. First, you take water and you split it into hydrogen and oxygen, and you get a hydrogen source using that. The splitting is done by electrolysis, and the electricity source is a renewable energy source, such as solar, wind, or hydro. Next is the carbon capture part. There are various sources of carbon, and you capture that carbon and use the hydrogen and carbon to make a fuel using various processes of synthesis. Next is to conclude, electrofuels aren't the one solution, but they're a really important piece of the puzzle. They fill in the gaps where batteries don't work. And with falling costs and better policies, they could help us reach net zero emissions without waiting for a brand new technology to be invented. Thank you.